are not randomly scattered around. You see that? They're in patches. Likewise, green is for vertical. You can see cells maximally responsive to green light are scattered around, and so on for a variety of other colors. So kind of like with the ocular dominance columns, orientation-sensitive cells, that's the word they use here, orientation-sensitive cells are not randomly scattered about. They occur in little clumps. Furthermore, sometimes at least, there's a real order to it. Like, look at this spot right there. You see where I'm pointing? Look at that spot right there. Let's see. To the lower right of it, we have cells that like vertical. You go up here, we got cells that like tilted off to the right a little bit. We got here, we got tilted to the left. We got there, we got them almost vertical. We got here, tilted off this way. In other words, it's as though the preferred orientation sort of turns around. I always want to be a cheerleader. That's as fast as I could do it, though. It's as though at some places there's a logical, systematic change in the preferred orientation. So these are so-called orientation columns. They don't really look like columns at all. They look more like pinwheels, and the recent literature tends to call them pinwheels. But again, you can see orientation preference is not randomly scattered. I'll show you one last figure, and then we'll wrap it up for today, and I don't know what I'll do for next time. It turns out it's possible in humans to use very fancy special techniques and do ultra-high yield fMRI that gives you very high resolution. And these are studies in humans in which this is one little patch of primary visual cortex. In the left-hand part of this, they exposed the person's eye, either their right eye or their left eye, to light. Does that make sense? So these are those ocular dominance columns we talked about before. So just like in the monkey, there are alternating bands within the cortex that respond to stimulation of the right or left eye. Here, they exposed animals to line segments of various different orientations, just like I described before. And the various colors here represent patches of cortex that were excited by light at specific orientations. The whole thing is fantastic. So imposed on a little bit of cortex are two topographic schemes. One of them right or left eye, and then on top of that, the exact angle that the line segment is at. I mean, this is fantastic. There's a lot of analysis being done in the visual cortex, and it's not being done in sort of a random fashion. There is an organization to the way in which this occurs. Gee, I got through about 20 minutes less than I'd hoped to, and I do feel like a total idiot. I just knew that was going to happen, just like it did. I didn't think to push that button. Next time we will continue from here, and this I hope will get more interesting. I hope.